So here I'm going to show everybody how simple it is to actually make a spaceship. No, not rocket ship. One of these bloody stupid looking things. This is just whatever it is, but I'm talking about if this was the top up of the shuttle, as in spaceship, one of these flying saucers. It can be done with remote control much easier, but we'll go to the next lesson for that one, which works perfectly, okay, much easier to explain. But this one, I'm going to show you how to do it with actually wiring. You know, so impossible if you know a little bit about this. No. I don't know anything about electricians. I don't do that job. I don't know about positive and negative, but no, nothing like that. Okay. Wiring, I'm concerned that if you plug wiring here as in electric wires, even if you do a perfect job, you've done it all wrong. This thing has to defy the law of gravity in order for the wires to be put correctly, as well as the wires to be put at the exact right spot of the shuttle, that is the space shuttle. Otherwise, when this turns one way and the other thing the other, whatever is happening in the turn, the wires, even if they're put correctly, they're going to tangle up. It's going to turn and they're going to tangle up and you've got problems. Common sense says common sense, right? So what you've got to do, now I'll explain this to my own, but I don't think you understand it because you haven't done it yet. So I'm going to try to explain this by showing you. See, it's got to have something here, not the wiring. It's got to have, it could be fatter or thinner, depends upon what's stronger and what works best, okay? Shuttle has to be light. You have to have a dead center like this, okay? So we'll take this off. It's not been put there yet, so you can understand it. Here it's got to be higher. One wire only, not for the purpose of electricity. I don't know if you've done this before, if you can, but for the purpose of giving a signal. Okay? Okay? So you've got a wire going straight up here. Just one dead center, has to be exactly dead center. So when this turns, the wire is only turning in the same spot like this. It's not entangled. Don't worry about the bottom at the moment, I'll show you. You can put the wires everywhere and it's still untangled, but that's later, comes on later. But if this is put just a little bit that way and it's got two, it's going to tangle because it's not that center. You understand that? Okay. So you have to actually defy the law of gravity here, in the sense that you're not actually doing that, but it's no different than you actually are. And it actually looks like you are if you actually, well, you can't see that. But if you actually know what you're doing, it actually appears something similar to that. Okay, don't know what, but it's very similar to that. So what you've got to do is, now, you've got to pay attention here because it's very complicated to explain. So I'm going to have to explain it a few times until I explain it right, because this can go in many directions and it can even be explained wrong. Alright? So to explain it right, I'm going to have to tell you a few things, okay? I'm going to show you a few different ways, and then you will know which way is the best way, okay? So you got the signal coming in here, okay? You got wires wherever you want to put them here, okay? Doesn't matter, okay? In this method, not necessarily others, okay? So you got just a signal dead center. It has to be exactly dead center. So when this turns, the wire's just going to turn like this, same spot. Okay, this is going to have a connection right there. And here is where it's got to defy the law of gravity between this and that. And here, everywhere, all over the place. Okay, so you've got, hang on, let me think. So here in the joint, let me think, okay. In the joint, you've got a wire coming up here. It's stuck onto this somewhere. Okay? So you've got, something like this in here, and stuck in there, like up there, not too far. And this part doesn't have to defy the law of gravity in this method. You can actually stick it here, but it's to be done strong, dead center, and that it doesn't break. Okay? So when this turns, the top part will turn with it. See? Although, got another problem here. Although, the way and I'll show you how to actually do this even though there's no oxygen in space, okay? Because helicopters need oxygen for the propeller. This doesn't work as a shuttle, this works because inside, this is the correct shape, but if it was, you've got a propeller there like a helicopter, for crying out loud. 2 or whatever it's got, as many as a helicopter has, I don't know, you work it out. So this is turning this one way, while the propellers are turning the other, clockwise or anti-clockwise, doesn't matter. But one has to move one way and the other the other. Okay, so this is where it becomes complicated. Even if you understand it, it's so easy, it becomes complicated in the human mind, doesn't it? Because what you've got to do is you've got to turn this one that way, for example, one way, and the propellers the other, in order to get that effect. And you've got to have oxygen. In space there's no oxygen, but we'll get to the point, okay? So we've got this here, okay? Going around this one. Say one way, not both ways, one way. Or it can be changed around 2 ways if you want. But one has to go one way always, the other way, okay? Clockwise or anti-clockwise, doesn't really matter which way goes what. As long as one goes one way, the other, because this is what's going to cause the power with the propeller. Okay, so when it's propelling, so you understand that part, simple. That I'm going to show you how that works in a moment, but simple in its understanding up to now, right? Okay, right. Next step. So when the propeller is done, you got this way. We have to come on its edge here. Okay, its edge here. Somewhere is one way. We're at the right place. I'm not saying that's the right place. It could be wherever it's the right place. You can have 2, one on top, one on the bottom. Okay? You can actually have it 3 ways. One, stick to 2 for now. Okay? So this is going one way, the other one's going the other way. So this is turning with this. That's a turn with it. One way. Okay? Well, the propellers are going the other way. You need barbarians for this. Big ones, small ones, whatever size they are needed. It depends on how big you make the shuttle and whatever, okay? So you need them. So you need barbarians to okay, this method is different to what I explained in the book. Okay, so let's see if this one will work. We'll work it out now because I'm coming up with a better idea right now. But anyway, we'll see if it works. If not, we get back to the other idea. Okay, so it goes here, let me think. Let's turn it. Yeah, it will work. So underneath here, you've got a floor. Right? This floor, now hang on, we have to change it a bit now, it gets complicated. This floor here has to stand still, not move, because the astronauts have to walk on here, and if you move, they're going to bloody go merry-go-round and they're going to go all over the fucking place. You want them standing still. You know, they may not move anyway, but you want it standing still, right? Okay, so how does this work? Okay, a number of ways. One way is you have to stick a whole dead center here, put this through the center, so you got it here. Now this is what's defying the law of gravity here, mostly. Not really, but watch. You're not here. You're right there, but I have to put it here so you can see it. Okay, so that's the center of the page. Okay, so underneath you've got a floor. This, by the way, has to be the right shape. Not necessarily this is the right shape. So is the bottom. Not necessarily. I'm just showing an example. Okay, so now you're in the bottom. So this has gone through the page off the floor, stuck on as well. Now this is turning exactly the same way as the top. Get the propellant side is turning the wrong way. The other way, hang on. Okay. Yeah. Okay. So this is turning together at the top one way and the propeller's turning the other. Anti-clockwise, clockwise, doesn't matter either way. Okay. But opposite for the two. Now you've got this moving on top, you've got that point. Okay, you've got that point. Okay, so once you do that, we'll get to the wiring in a minute. Okay. You've got the floor here, it's gone through the hole, up top. Now this has to stand still. Now this is, if this is attached anywhere to the shuttle, it's going to move with it, right? So how do you get a stand still? Now, I'm not sure exactly where to put these. I'm not a builder. I travel in time and space, but through the Holy Spirit here, not my own technology. But I understand this through how you explain it to me. It's got to have barbarians for crying out loud. Now, this is not straight. This is round, like this. So this is the floor. This is this. There's 1, 2, 3, not necessarily the same shape, like a floor now. Okay, I'm just giving you an example of a shape. It has to be the right shape of the floor, as in thickness, same roundness exactly, and same correct shape. This may be about correct shape or whatever. So you've got one up there, you've one here, you've got the floor. Okay, not too far away, but I'm putting them far away so you can see it. Okay, so it has to be joined together. Okay, it has to be joined into one, about this big. So in the center, now this becomes the floor. Okay, now this won't be that fat, it'll be a lot skinnier, unless you want it that fat for whatever reason, whatever works. And around it is where you guys put the barbarians for crying out loud, right around it. Okay, so this is the floor. It's the floor. So while the shuttle is moving here one way, and you've got the propellers working direct opposite, the floor with the barbarian moving is standing right at the same spot if you get the exact effect. It's got the barbarians to move, yet because the top and bottom is moving it with the propeller, it basically means that okay, the floor will stand still. Hang on a minute. Okay, hang on a minute. There's something here going on. Okay, hang on a minute. This new one. Okay, you've got it here. You can do it that way, or you might have to have the bottom. It's got me going. It's something to do with that. Okay, so the barbarians here. It's right around. This would turn. This would turn. And just stay there. But a better way of doing that might be better, either this way for the floor or the reverse. I'm not sure which way you've got to work it out. It's one of the two. Has to be. So you've got the top moving one way, the helicopter the reverse, and this may mean that it has to reverse the opposite way, which would get a better effect. You know, exactly how the helicopter moves. So you've got this going on the floor that way, and the top going the reverse, and that will keep the floor balance, because the pressure of this and the pressure of the top is keeping it in one spot, because the barbarians to do that. No different than define the law of gravity with the floor, see? Although it's got the barbarians to help. It's got to be oiled, whatever. So either one way or the other for the floor, work it out. You are the technicians, okay? Could be both, but I think the second one will work much better. Okay? I'm not sure the first one will, but if not, the first one will. Anyway, so you got that happening, right? Do you understand that? Would that work? Okay, so here is the, okay, so you got that happening. But here we've got the helicopter method now. It would, if there's an opening, and you might have one in this case, unless you're on Earth, but if the propeller is turning here, it needs oxygen for the propeller to work, right? And it will work on Earth as an aircraft. How do you get the oxygen up there? When there's no oxygen up there, I'm talking about. Now you can actually get the oxygen. You can continually have a full life supply. Well, as much as is there. So on the floor here, now this is round like this, okay? The floor, but I'll use this so I can show you. On the floor here, you have a system of plantation here. Yeah, any tree that you want, and it can be used for food. As much as oxygen is needed for the helicopter to rotate in here. That's what you need. The helicopter to rotate here. It doesn't need it out there. It's not doing anything there. It's doing it in here. Nothing to do with it out there. In here. You have to have enough oxygen in those, as much as the helicopter needs, though, to continue the journey not on Earth, because it's got it there, in space. So you've got plants here producing oxygen, and you've got animals, whatever, whole farm, in other words, here in the mothership. This will provide food and, you know, and all that type of stuff, and also oxygen. right? And you make sure it becomes the proper amount. This will be a continuous supply of oxygen, just like Earth is round, and and you've got the Earth here, and there's always oxygen here on planet Earth, except it's in a smaller shuttle, maybe as big as a mothership, but much smaller than Earth, no different. That's all you need to know for that one. Okay. To understand it, you can have other things here as well. You can have sections. You have computers running all right around. Depends how you want to do it. You can have 1, 2, 3, 4. You can have all computers running around. You keep it like that, it's better because it creates the same shape, a more better understanding than too many shapes that confuses you, like a cross, and then you've got round, and you've got whatever else. The farm may have to be done that way, but that's fine, because it has to be done. Things that have to be done have to be done. Not necessarily computers, you can put them right around like this. You've got more control of the shuttle. One breaks, you've got the other one, whatever, okay? You can use whatever, okay, so you got that, right? So all you need is one wire now. We'll go back to the wire method. Now here we're talking about the first method, one of the methods with the wiring, is that you need some sort of wire. I'm not sure if you got this, but you're going to use some wire that's connected on the top of this. Here. Dead center. Not even a little bit out, because if you move it's going to tangle. It doesn't matter how fat it is, it just has to be dead center of the shell here and dead center of the other. Exactly. Okay? Here. The bottom would be, no, hang on, where would it be? It would be under here. This is the floor, okay? This is the floor. Round, like the shuttle on the floor. To its right thickness, okay? Say this is round and this is the floor. As it's over, the wires now have to be stuck under here. Because this is not moving. So it won't get tangled. This is defying the law of gravity here. It's a matter of speech, okay? So they go into wherever you want to put them, into the computer department. Now you've got the signal into the computer. Signal whatever you want. Back to base. You've got the electric wires straight there. Remote control. Using one signal method. You can also have the signal in the computers as well. Okay. Or many signals in each computer for security. So you can always signal remote control on Earth, so you don't get, you can have so many computers there that you never lose, the remote control from Earth. If something stuffs up, you use another computer and so does Earth. See, so then okay, so you got that right, okay. So there's more to this to be told that will be even better relating to this. I'll show you other ways, maybe if I've got time. You know how to do this, I think 2 or 3 ways. I don't remember if they all work, but this one does, as you see, okay. I think this one I just changed it a little bit compared to the previous theory. I think it's better. But anyway, I don't know, and this is the same anyway. Yeah, I'll think about this off camera if I told you pinpoint accurate. I think I did. If I made a mistake, I'll come back and correct it, okay? Because it's very complicated to think on this. Just the thought is complicated. Then the paperwork is even harder, and then the actual building, okay? It's simple to understand, but very weird kind of thing. Because past people see. Okay, so this shuttle idea, it works perfectly. As I said, everything that I said before is accurate except the wiring. I made a mistake on the wiring, I think. In this new one, I came up with it just now. My plans are slightly different. So this one was a new idea, most of it based on the same principle, kind of way. So everything's correct there, to my knowledge. One way or the other for the floor. That is for the floor. Hang on, the under part, not the floor, the under part. Work on that one. It's one or the other. Now, in this one, the wiring is not actually right because we're dealing with a different thing to what I thought last time. Therefore, it's actually going to tangle with the floor, because this is turning. So in order not to do that, you've got to have the wires now in a different location. And you need another one of these under. Well, bearings again, I think. Hang on. Give me a second. Hang on. Well, bearings here again. So this is turning one way. Okay, top is turning the other same way. Propeller's turning the direct opposite. Hang on. Whoa, this is confusing. I can't even explain this. I've got to explain it properly. But anyway, get to the wiring. The wiring has to go in here. And this time has to have another floor here, where it goes onto that floor. So this and the one that's attached to the wires will remain at the same spot. In a way, it doesn't get tangled. You have a whole lot of mumbo jumbo bearings everywhere. But anyway, big ones. So let me think now. Let me just get a mesh right here because my fan's going to blow the top of the scene. We get smoking here and there. Okay. So let me think for a moment. This is kind of like the new one, the new idea that I'm thinking of. So you got the floor, the top going that way. Yeah. You have to have another thing like this underneath here for this method. Where's the other pen? What to do with the other pen here? So this is the actual pulp that goes on the shuttle, for example. You've got to have a little one underneath here to fit to the other floor here. And here. Okay, so what that will do is got the wire going from here into that. Okay, so you've got the signal here. This is turning one way. That one, bottom. Okay. Be back in a moment while we work on this, okay? I need some time to think. Okay, so when I call the space mission NASA, I'm talking about Australian space mission, American, USSR. I'm talking about the whole planet, as in working together. Okay, so yeah, I just call it NASA. Okay, anyway, so this is the top part. Okay, we got this here, not that big. We got that here. Well, that has to be joint. This is too big. It has to be, you know, like this size. Okay, so it can fit. So here, and it has to have the floor, as explained. It's going to be the same thickness here, same here, for example. Now, what you do is when this is attached here, the floor is going up one way, and the other clockwise, and the roof is going anti-clockwise, for example. Now here, the center has to have a round thing here, cut, and joint there. So this is on that little thing here, stuck. Around here has to have ball bearings. And then you have to have something up here to hold it like this. Okay? Okay? Goes through that. Okay. Okay. I'll explain it some other time. And then you've got the same thing on the bottom. Okay? Something similar on the bottom. Okay? So, there you have it. Okay? Now, fiddle around with that. Take care. Okay, so continuing from before, you know this totally remote control, and yeah, it's, you know, wiring like this. But, if you're going to put wiring, here's the dead center. Okay, the wiring has to go between that. That's got to be hollow. It's got to be attached somewhere in here, and this has to be on the touch. Okay. So, for example, now we change this, and this is wires. Okay, now this is the wires. Okay, because you can have two like this, positive and negative. Okay, they have to be stuck together, but the wiring has to come out that way. Okay, so it doesn't touch. Okay, something like that. Okay, and here. Okay, at the bottom. So this will turn exactly the same way because the roof is going this way. the top and the bottom's going the other way, not the same way. The floor is there, it's got barbarians, so the barbarians that turn are not turning the floor, they're turning this. It's going that way, this is going that way, so this is staying, you know, if this is the floor, it's staying like that. And the under it is turning one way, the top is turning that way, so that will keep the floor there. Underneath goes under the floor, stick the engines, okay? Okay, so yeah, you can have wiring coming into the floor, computer department, you know, from the engine or at the engine, that is, wherever you want to put them. Okay, you can have everything on the floor, on top. You can have things under the floor, attached under the floor, okay? You can also have the farm. You've got a whole plantation here. I'm talking about planet Earth, a small planet Earth shuttle, okay? The size, that sort of size, okay? So you've got the oxygen coming. You need to make enough oxygen for the astronauts and also for the they don't recommend you use astronauts yet, but when it works, okay, when you get the technology to do that. But I mean, yeah, don't use a monkey. You use a robot until it's safe. But anyway, so how this works with fuel is with oxygen. Okay, so what you do is you can have bottles here onto the pole. This is the pole. Fat, skinny, this is the pole. Wires are in there, okay? The wires, okay? So you can have bottles like this right around with, filled with oxygen. And so you make enough oxygen for the astronauts and the bottles. Right? If it starts to run out, you've got to pause it, the shuttle or something, and wait the bottles fill up. Your own petrol station is there. Produces its own, not petrol, oxygen. From the fuel tanks, which has got oxygen, you release it out of the shuttles. Yeah. You can have right next to it, like this. You can release it one way, so it's going this way, you release it the other way, stop that one and release the other one. Go in any direction, you just stop one, release, and the other. The basic principle is to have 4. Okay, and have 4 like across here. Shoot it one way, you want to go the other way, you go that way. You just stop that one and release that one, so on. Okay, you can have 8. Okay, basic principle. Because when this is like this, you've got 1. Okay, you put it right around. Okay, so on the pole. There's the pole. The oxygen tanks. So you can have the engine underneath, as I was explaining, because the floor is standing still. It's very much barbarians holding it. Okay. Okay. So yeah. From there, you can shoot out oxygen in space, for example, and fill up the universe. One shuttle will take a bloody long time. Okay. So it's going to do it slowly. So you release oxygen into orbit. You can do it with more shuttles as the future progresses and it becomes like a traffic jam up there. That's what's going to happen. Just like there's car jams here. Okay, it's going to have to be controlled up there. You also have you can create life in Mars and other planets. I'm sure you've got that type of ways of doing it. And when you do that, you can keep you have to keep the oxygen in one area where the planet is, but have some way to release the oxygen in space as well from there. Okay, the extra oxygen. Okay, eventually, you know, if you can control it into the galaxy, okay, they can fill up the whole galaxy with oxygen. And it's going to take a long time. You have a lot of aircrafts doing this. There are a lot of space shuttles, and you know, it'll take a long time to actually create this. But once you do that, you can have a plantation on each planet and release the extra oxygen into space. You can have plantations in space stations. and release the oxygen from there. As time progresses in the future, you can go beyond the galaxy and go all the way to all the universe. Slowly, it's going to take a long time, but anyway. So once there's oxygen, say, in the galaxy, you don't need this future technology of shuttle. You can use it from Earth to go to orbit, or you can use rocket ships. But once it's in orbit, you can have planes right here, a bit higher than the computer is somewhere, okay, and shoot them off. Yeah, you can have openings in the shuttle, shoot them off. Now you've got planes and helicopters flying in space. The old technology becomes a lot better now, because we're really good with the planes and the helicopters. Okay? So if you fill up space with a lot of oxygen, then you can use helicopters, and you can also use planes. You can use them with oxygen. You don't need petrol. You can run it with oxygen. That's all there is to it. I'm not sure if there's anything more there, but that's the basic big picture. You can add other things, other features into it, whatever. I don't know if I've missed anything. I don't think I have. Be back if I have, okay? Okay, take care. Okay, so here on both sides, here in the back, got the circle here, okay? And you've got bearings going this way. You've got a flat piece going on top here, and one on the under to hold the bearings together, top and bottom, a thin layer, okay? Okay, above it, you've got something like this, a round thing here. This is for the astronauts to go in there, and you've got holes you can go in, okay, in and out, okay, it has to be balanced, okay. So that is 4, 1, 2, 3, 4 openings, and you've got to shoot here, around one, okay, and that's got the bearings going this way, okay. And it's let's get stuck onto hang on. Work on that. It can be stuck on the plate here. So you got the round circle here, put bearings in here, and on top of it you got a thin layer stuck only onto this, not onto this. And on the bottom, so you've got it here, in there. This turns and stays on there. Okay, alright, like that. Okay, stays like that, turns like that. On top of it, okay, you got a round thing going like this, stuck onto the plate. Can be stuck on there. Okay. So you've got where the circle is here. In between it, you've got a cutaway. You know, enough for the astronauts to fit in there. Okay. So then when this turns, you know, they can fit in. Don't touch the sides though, okay, but it's got to be big enough so they don't touch the sides, okay. And there you've got astronauts. You can have telescopes if you like, prefer. If you put telescopes, you don't need astronauts up there, because it's a bit dangerous to get through that gap when it's turning, okay. Not if it's wide enough, but anyway. You can have telescopes in any direction that you want and have a look. You can have it under as well. Okay, so that's how it works. You can have the round shape here. You can have, you know, something like this, a smaller version of this at the bottom here. Whatever shape works best. This is just an ashtray, just giving you a sample of a saucer. It may be this shape, okay? Maybe this shape, okay? You work out the shape, okay? Okay, so yeah, let's go to the saucer, okay? Yeah, take it. Okay, so if this is a saucer, You can have things sticking out here, not this big, but just a little bit like this, just a few here like this, wherever you want them. Shoot the air out, it goes one way. Okay, so this will be turning, so you have to know how to drive it, because as soon as you turn it, it's going to go like that. See, it's not going to go straight because it's turning. Okay, so you need to know how to drive this. Get a driver license from a Namian, okay? You learn, just like we learn the cars, just like we learn the helicopters, just like we learn the planes, the boats. You learn this, so it'll be tricky because you shoot it this way, it's going to go that way, okay? Because the thing is turning. Although, if the other one's turning at the same time, then what happens? It's balanced. Shoot, wherever you shoot it, you'll go straight to where you're shooting it, see? Yeah. Not if they're going the same way. Because if they're going the same way, you're shooting and go boom like that, see? Out of control. But if you're turning one way and the other, those clockwise and anti-clockwise, then it's going to keep it balanced like that, see? Okay, so, yeah. Okay, so, yeah, that's why they pause. Because when that turns, it's got to find the holes. See, this is here. Okay, turns in the inside. Okay, so I'll explain that more. Work it out. It's got to have another thin layer in there where it closes the hole. So when it, like, how do I explain this one? Yeah. So when that when this turns, if this is the inside, there's a layer like this on the outside. Okay, when it turns in the inside, this is where it's got the hole. So where this hole is, so there's one. Okay, on the outer layer, it's exactly the same way. So that closes it when it turns. Okay, and you got the air coming ready to shoot. As soon as it turns, shoots the air out automatically just by turning this, the inside layer, and fitting it exactly to the hole. Okay, so you've got another layer coming like this, see? Another layer like this on top here. Okay, turns, as soon as it finds the hole, matches with the other hole. That's why you see them going, because it's got a slight pause. You look at the sightings because of that. Okay, so, alright, or something similar to that. Okay, so, yeah, alright. Okay, so here's where the holes are. It could be everywhere, you know, wherever you want them, you know, neatly, like right around. So the inner layer, it's got all the holes. Doors are shut. Remote control, they're open. Okay, so the outer layer is exactly like this. So you want to go here. So you want to open that hole. Remote control, the doors open only on that hole, see? And then shoots up that way. When this turns and is placed at the exact position of the outer hole, the outer hole is always open. You can actually have doors to shut it if you want, but okay, so everything has to be balanced. So if you're going to do something, for example, you have to have, if you're going to have aircraft, you have to have 4 balance. You can't have 2. You can, but it's going to weigh it a bit. Okay, so 8. Everything you do, you try to do it in the balanced way. The shuttle, put it exactly where it's balanced for better results. Okay, you can add a lot of things to this. Okay, so yeah, so that's why there's a pause there for a split second or something. So yeah, thank you for listening. There's probably more involved in this. You got to look into it. Okay, but that's the basic big plan about it, the big view of it. You can add a lot of things to it though if you want. Okay, but that's all you need. Thank you. Okay, so everything in this has to be balanced. So the top part spins clockwise. So the inside layer, the outside goes the opposite. and reverse for inside and outside for the bottom one. Okay. Between the layers, yeah, has to be done correctly so they can slide. Okay, they will slide. Yeah, you can put barbarians in certain places, like you got a gap here. Okay, so you put barbarians here on the inside layer properly, so it doesn't, go that way. The inside layer, and on the bottom one as well. Okay, and maybe up here, for example. See, you got a gap there, so you put here as well. If this was a shape, yeah, it's got to be the right shape. And if that was the right shape, that's how you do it on that area there. Okay, so it can be many shapes, but correct shapes. Okay, so yeah, all right. So now that you understand that, it keeps the shadow balanced, because if there's only one on the top, and one clockwise and one in the reverse, it's kind of like, shaking a little bit. Okay, it still works, but well, it works with both layers. Okay, that is all. I can't think of anything else. Be back in a moment if I do.